All right, let's talk about Java. It's one of the biggest programming languages on the planet, running, well, just about everything. But its real power, its secret sauce, is how it brings order to the potential chaos of coding. It's all about structure. So, how does it pull that off? Let's get into it. To really get why Java is the way it is, you have to look at what came before. Code used to be a mess. This quote nails it. It was like a plate of spaghetti. Just a tangled web of commands that was an absolute nightmare to read, let alone fix. This chaos is the exact problem Java was designed to solve. So here's how we're going to break it all down. First, we'll look at why Java was even needed in the first place. Then, we'll dissect a program piece by piece. After that, we'll get into the basic ingredients of code, see how it makes decisions, and then explore its most powerful idea, these things called blueprints. And finally, we'll take a quick peek at what comes next. Okay, section 1, taming that spaghetti code. To see why Java was such a big deal, you have to understand this one little command that caused so much trouble in older programming languages. The culprit was a command called goto, and it did exactly what it sounds like. It let a programmer jump from any line of code to any other line whenever they wanted. Imagine trying to follow a recipe where step 2 tells you to jump to step 9, and then step 9 sends you back to step 4. It was a mess. Java got rid of that completely, forcing code to flow in a logical, structured way. All right, on to section 2. Let's see what that structure looks like in the real world. You see, to avoid all that chaos, every single Java program needs one single, unmistakable starting point. Think of it like the front door to your house. And this is it. This is the main method. This exact line of code is literally the on switch for your program. It's the very first thing Java looks for. And what's really fascinating is that every single word here, public, static, void, has a super important job. Let's break them down. So first up, public. It's called an access modifier, which is just a fancy way of saying it sets the visibility. Public means this method is totally open for business. Anyone or anything can see it and use it. And that's critical because the Java system itself needs to be able to find this front door to get things started. Next, we have static. Now, this one is absolutely crucial. It means the main method can be run directly without needing to create any other parts of the program first. It's like having a key that starts the car's engine without you having to build the car first. It makes it the perfect way to kick everything off. And last but not least, void. This one's pretty simple. It just means that when the main method is done running, it doesn't report anything back. It doesn't return a value or a message. It just does its job and then it's finished. That's it. Okay, section 3. We know where the program starts. Now let's look at the basic ingredients. At the end of the day, all a program really does is manage data, right? And to do that, you need containers to hold that data. In Java, these are called primitive data types. Think of them as the most basic building blocks you can get. You've got different containers for different jobs, some for whole numbers, some for numbers with decimals, a special one for single letters or symbols, and a really simple one that's just an on or off switch, true or false. Let's just zoom in on the two most common types you'll see. An int is for integers, your basic whole numbers. You use it for things like counting stuff. A double is for anything that needs a decimal point, like calculating a price or working with scientific data. It's all about picking the right tool for the right job, which keeps your code running smoothly. Moving on to section 4. So we have our data, our ingredients, but a program isn't just a list of ingredients. It's a recipe. It needs to follow steps and make decisions along the way. This is where we give our code a brain. This is a super common pattern called an if-else-if ladder. It lets the program ask a series of questions. First it asks, hey, is the month a winter month? If the answer is no, it moves on. Okay, well, is it a spring month? If yes, it sets the season to spring and stops asking questions. It's a really clean, logical way to make one choice out of many possibilities. And boom, here's the result. If we tell the program the month is 4 for April, it runs through that logic we just saw, figures out it's spring, and prints this exact message. It's that classic pattern. You give it input, it processes it, and it gives you an output. But what if you need to do something over and over again? That's where loops come in. This is called a for each loop, and it's so elegant. It basically says, for every single number, which we'll call x, inside our list of numbers, I want you to add it to our running total. It's simple, it's easy to read, and it avoids a lot of silly mistakes. So after that loop runs through all 10 numbers in our list, our sum variable ends up holding the final answer, 55. And that's the magic of loops. You can automate a really tedious task with just a few lines of code. Now, section 5. This is where things get really, really powerful. We've seen the basic ingredients and the logic. Now we're ready for the big idea that really defines Java, object-oriented programming. And it all starts with the idea of a blueprint. So a class, it's not the thing itself, it's the plan for the thing. Think about a blueprint for a house. The blueprint says the house will have, say, 3 bedrooms and 2 bathrooms. But the blueprint isn't the actual house you can live in, right? It's just the design. Let's make that real. Here, we're defining a class called box. This is our blueprint. All it says is that any box we decide to create later on must have these 3 specific properties: a width, a height, and a depth. And here's the most important part. Once we have that box blueprint, we can create as many actual individual boxes as we want. We call those objects, and each one is its own separate thing. If I change the width of my first box, it has 0 effect on my second box. They're totally independent, even though they were built from the exact same plan. And that brings us to our final section, what's next? We've covered the absolute core fundamentals, the structure, the data, the logic, and the blueprints. But that foundation opens up a whole new world of possibilities. The journey from here gets into some incredibly powerful stuff. Inheritance lets you create new blueprints based on old ones, which saves a ton of work. Multithreading lets your program do multiple things at the same time, making it feel way faster. And other concepts like generics and exception handling are all about making your code safer, stronger, and more reliable. So from its early days of taming spaghetti code all the way to this elegant system of reusable blueprints, Java gives you this incredibly solid foundation for building things. The only question left is, what would you build with it?